Have you ever wondered what allows a robot arm to reach certain places while being completely unable to touch others? It is a fascinating dance between design and capability. Degrees of freedom directly determine a robot's workspace, shaping the range of positions and orientations its end effector, or gripper, can achieve. Essentially, the robot workspace is the entire volume of space that its end effector can reach. The core mechanism behind this impact lies in the definition of degrees of freedom. Each degree of freedom represents an independent parameter that specifies the configuration of a robotic manipulator. These typically correspond to joints, which allow either rotational movement, known as a revolute joint, or linear movement, referred to as a prismatic joint. Each additional degree of freedom generally expands the robot's ability to position itself in three-dimensional space and to orient its end effector in various ways. For instance, achieving an arbitrary position and orientation in three-dimensional space typically requires 6 degrees of freedom. Fewer than 6 might restrict either the reachable positions or the possible orientations at those positions. Understanding this relationship is crucial for both designing and selecting robotic systems. When engineers develop a robot, they carefully choose the number and type of degrees of freedom based on the intended tasks. A robot needing to perform simple pick and place operations within a limited area might requiring fewer degrees of freedom compared to one designed for complex assembly, which needs to reach around obstacles and orient tools precisely. Analyzing the required workspace and dexterity for an application directly dictates the minimum number of degrees of freedom needed. An interesting nuance in robotics is the concept of kinematic redundancy, which occurs when a robot has more degrees of freedom than are strictly necessary to perform a given task. This redundancy, often 7 degrees of freedom or more for a typical arm, can be highly advantageous. It allows the robot to achieve a desired end effector pose in multiple ways, providing flexibility for obstacle avoidance or navigating around singularities, which are configurations where the robot loses its ability to move in certain directions. The arrangement of joints, whether serial or parallel, also significantly influences the overall shape and accessibility of the workspace, not just the sheer number of degrees of freedom. Ultimately, degrees of freedom are a fundamental determinant of a robot's physical capabilities. A thoughtful selection and arrangement of these independent movements enable a robot to perform its intended functions effectively, optimizing both its reach and its dexterity within its operational environment. This understanding is key to unlocking the full potential of any robotic system.
If you love robotics, like, subscribe, and keep building with us.